Hello everyone and welcome back to DBX Labs. In today's video we are going to take a pass from working with energetics and instead make concentrated ammonia solution from urine. So as many of you may know, urine is primarily composed of urea dissolved in water. Urea in itself is a waste product derived from amino acids in the body when they are broken down by the kidneys. With the addition of a strong base, urea can be easily broken down into 2 molecules of ammonia and 1 molecule of carbon dioxide. This is the route that we will be using to produce our ammonia gas in this reaction. To do this, however, we are going to need to concentrate our urea into a smaller volume of water. This is simply because urine is only of 1 to 2% concentration of urea by weight, meaning that my 3 liters of urine likely only contains about 30 to 60 grams of urea dissolved in that 3 liters. Now, because urea is extremely water soluble, it's very simple to concentrate it in water. All we have to do is boil down our pee until we have a smaller volume that's easier to work with. Now, I should note this is not the easiest way to make ammonia. You can produce ammonia gas from nearly any ammonium-containing salt. This synthesis is purely done out of curiosity as to whether it is actually possible to produce a concentrated ammonia solution from urine. And even still, it's a really bad idea to do this in the first place, considering that boiling urine doesn't really smell well, and it really isn't going to be making any of your neighbors happy with you. I think even saying that is enough said, but I'll go one step further. This reaction made me gag on numerous occasions due to the fact that concentrated pee smells a heck of a lot worse than regular pee. So do not try this unless you want your clothes and everything around your lab to smell like concentrated urine for days. So to start out, we take a 1 liter beaker, fill it most of the way up with urine, and throw in a stir bar. That stir bar is going to allow us to break down the bubbles that form as the pee starts boiling. And that really becomes a problem later on when the pee really thickens, because the boiling results in the formation of pee foam. And pee foam doesn't go away that easily. You really have to break it down with the addition of a stir bar and rapid stirring. We start boiling the pee down, and when it gets to around 200 to 300 milliliters, it really starts to thicken up. We see a lot more foaming, and this is also when we see a precipitate of what I can only assume to be minerals that settled to the bottom of the beaker. At this point, I let the precipitate settle and decant off the black liquor that is our solution. This concentrated pee goes into a separate beaker, and we repeat the process in the large beaker again and again until we concentrate all of our pee into a very thick black mass of concentrated urine. At this point, I further concentrated the concentrated urine by pouring it back into the larger beaker and boiling it down again. The only problem was that as soon as it started bubbling at all, we saw again the formation of a lot of pee foam, and that really resided there throughout the boiling, and it never settled down. So I had a little bit of overflowing of pee foam onto my hot plate. When we decant off the more concentrated pee, we see again we have a precipitate. When we add that precipitate to our other precipitate, we see there's a considerable amount of insoluble gunk that's in the urine to start with. And I don't really know what to do with this. I mean, it smells horrible. If you guys have any ideas for what I should do with this, what I could try to do with this, put them in the comments. Otherwise, it's just going to dry and sit outside. So now we have our concentrated pee, and we have about 300 milliliters of it. In the next step, we are going to question our life choices. What led us here? Why did we boil pee? Why do we need boiled pee? And what are we going to do with it? While we ponder these questions, we prepare a concentrated sodium hydroxide solution in a large Erlenmeyer flask. This can be of arbitrary quantity. I really don't know how much urea is in the urine that I used. It was my urine, but I really don't know how much urea I metabolized. For this reason, we're basically just throwing a random amount of sodium hydroxide into water and hoping it's concentrated enough to react with our urea in the urine at a high temperature. Once we've prepared our solution, we put it on a hot plate and start heating it up. The reaction between the urea and the base proceeds at roughly 60 to 100 degrees Celsius, so we crank up the heat and get our concentrated P solution ready to go. Once we add the first half of the P solution in, it takes about 10 minutes for it to start rapidly evolving ammonia gas. This ammonia gas is led through a latex tube into a second Erlenmeyer flask where it goes right above the surface of some distilled water, which is rapidly stirring. By keeping the latex tube right above the surface of the distilled water, suckback is not a problem, and the decrease in yield due to the loss of ammonia I feel is negligible. It is important to use distilled water to absorb the ammonia and produce ammonium hydroxide, because otherwise you're likely going to react the ammonia with carbonates in tap water, and ammonium carbonate isn't as soluble, so it will likely precipitate out and leave you with a cloudy product. We can see the presence of ammonia by placing a damp piece of litmus paper at the opening of the second Erlenmeyer. Exiting ammonia is dissolved into the water in the litmus paper, and this is indicated by the litmus paper turning purple. When both halves of the urine solution are done reacting with the sodium hydroxide, we can remove the latex tube. At this point, we can pour off our produced ammonium hydroxide solution into a small vessel for later testing. The tests that I will provide to show that this indeed is a concentrated solution of ammonia is first, as the vapors of ammonia and hydrochloric acid mix in the air, they form a fine suspension of ammonium chloride, which is visible as a small cloud. Second, I found that this ammonia solution is strong enough to react with elemental iodine to form nitrogen triiodide, otherwise known as touch powder. Though technically most ammonia solutions can do this, really weak ones like those found in Windex can't, so this is some indicator to an extent that it is concentrated. Lastly, I measured the density of this ammonium hydroxide solution to be roughly 0.93 grams per milliliter, which equates to roughly 13% ammonia by weight. In an upcoming video, I will react this ammonia solution with nitric acid produced from my nitrogen dioxide generator, a homemade Birkeland dyed reactor. This video will entail how to produce ammonium nitrate from just P and air. Hope you guys enjoyed watching, stay safe, and I'll catch you guys in the next video.